We're going to continue factoring, but talk about a different type of factoring, which is factoring by grouping. So we factor by grouping when we have 4 terms. So anytime you have 4 terms, you always want to try to group. You group in pairs of 2. You factor out the GCF until the parentheses match. And then you factor out the parentheses, group together the remaining terms. So let's look at the example down at the bottom. So we're going to group our first 2 terms and then group the second 2 terms. Just looking at our first parentheses, what's our GCF here? X squared, perfect. I'm going to divide out an x squared from both of them. Put that on the outside. When I take out an x squared, just from my first parentheses, what do I have left inside the parentheses? X minus 1, perfect. X squared divided by x squared is 1. What's the GCF in the second group? 2, so I'm going to divide out a 2 and put 2 on the outside. When I take out the GCF of the 2, when I divide it out, what am I left with? X minus 1. So in order to factor by grouping, your inside parentheses have to be exactly the same. So my parentheses are exactly the same. I have an x minus 1 and an x minus 1. So I'm going to pull that out first. So they kind of go together just to become just 1 x minus 1. And then the 2 terms on the outside go together for our second parentheses. So x squared plus 2. So this would be our answer. All right, let's look at number 1 on the next page. So we have 4 terms, which means we're going to factor by grouping. So I'm going to group the first 2 together and then group the second 2. What's the GCF from the first parentheses? 2 and how many x's? X squared. So I'm going to take out a 2x squared. So 8 divided by 2 would be 4. And if I have 5 x's and I take 2 away, how many am I left with? So 4x to the 3rd power. What's 6 divided by 2? 3. So minus 3. And then x squared divided by x squared would just cancel. If I have 2 x's and I take 2 away, I have no x's. So there's no x's. Any questions on what we just did there? All right, let's do it again. What's our GCF from the second group? 3. Can I take out an x? Does this 9 have an x there? Nope, so just 3. So I'm going to put plus 3 on the outside because it's a positive 3. What's 12 divided by 3? So 4x cubed and negative 9 divided by 3? Minus 3. Are my parentheses exactly the same? Yes. The same thing here and here. So I'm going to group those 2 together just to be 4x cubed minus 3. And then what's my other parentheses going to be? 2x squared plus 3. So the 2 things on the outside go together for your other parentheses. All right, number 2. We have 4 terms. So we're going to group the first 2, group the second 2. What's the GCF in the first group? X squared. So x squared goes to the outside. When I divide out an x squared, what am I left with? Well, if I have 3 x's and I take 2 away, how many am I left with? Just 1 x. And then what's x squared divided by x squared? Is it nothing? What's 5 divided by 5? 1. Don't forget, you need that 1 there. It doesn't just disappear. It becomes a 1. Think about it. Our coefficient out front is 1. So since the x's go away, we just leave the 1 there. What's our GCF from the second group? 5? Let's take out a 5. When I divide both of these by 5, what am I left with? What's negative 5x divided by 5? Negative x. What's negative 5 divided by 5? Negative 1. Are my inside parentheses exactly the same here? No, they're not. I need them to be exactly the same in order to factor by grouping. Is there anything else I could have done differently? I could have taken out a negative 5 as my GCF because the numbers are the same, but the signs are different. So let's change our sign. Let's take out a negative 5. So I'm going to pull out a negative 5 as my GCF. So negative 5x divided by negative 5 would be positive x. And what's negative 5 divided by negative 5? Positive 1. Now are my parentheses exactly the same? Yep. So I'm going to group the parentheses together. So what's going to go in my first parentheses? X plus 1. And then we group the outsides together. So what goes in the second parentheses? X squared minus 5. That would be our answer. Let's look at number 3. We're going to group the first two, group the second two. And here, what's our GCF in the first parentheses? X squared. Perfect. So we're going to take out an x squared. When we take out the x squared, what are we left with? X plus 5. What's our GCF in the second parentheses? 5. If we take out a 5, what are we left with?
X minus 5.
Negative x minus 5. Are inside parentheses exactly the same? No, Isla, what do we have to take out? Negative 5. We need to change the signs of our second parentheses to make it exactly the same. It has to be exactly the same. So I'm going to take out negative 5 for my GCF. And then what are we left with in our second parentheses? X plus 5. Now are parentheses exactly the same? Yep, so we're going to group those together. We have x plus 5. What would go in our second set of parentheses? X squared minus 5. Perfect. The two things from the outside go together. All right, let's look at number 4. We have 4 terms, so we're going to group the first two, group the second two. What's our GCF from the first group? X squared. I'm going to take out an x squared, put it on the outside. What are we left with when we divide out an x squared? 3x plus 1. Perfect. Now take out the GCF from the second part, and then we'll do the rest of it together. All right, what's our GCF from the second part? Negative what? Negative 5. So we take out a negative 5. When we take out a negative 5, what are we left with? 3x plus 1. Awesome. Are parentheses exactly the same? Yep, so one of our parentheses is going to be 3x plus 1. What's the other one? X squared minus 5. We're going to go to the next slide, which is again 5 and 6, but it says perfect square trinomials at the top. So perfect square trinomials are when the first term is a perfect square and the last term is a perfect square. So we want to kind of do the same thing that we did yesterday with our difference of squares. But here we're going to square root the first one. So what's the square root of x squared? X. We're going to square root this last one. What's the square root of 25? 5. In order to use this as a shortcut, we'll call it, the middle number is always going to be 2 times the first times the third. So 2 times x times 5. This is just to check to make sure that you can use the shortcut. What's 2 times x times 5? 10x. So we can use our shortcut here. So in the parentheses, we're going to put x and 5. And always whatever the sign is in the middle. So we have a plus sign in the middle. So that's going to be a plus sign in the middle of our answer here. And our parentheses are squared. So we have x plus 5 squared. We can kind of think about it when we don't have a number out front. What are 2 factors of 25 that add to 10? 5 and 5. So in our parentheses, we'd have x plus 5 times x plus 5. So since we have 2 of them, we just write it as squared. It gets a little bit more challenging where we can't just look and see what are factors of the last that add to the middle when we have a number out front. Sometimes when we have a number out front, it's easiest to see is our first term a perfect square and is our last term a perfect square, then this would be helpful. So let's look at number 6. So we have a perfect square at the front and in the back. So what's the square root of x squared? X. And what's the square root of 36? 6. So in the middle, do we have 2 times x times 6? That's 12x. So perfect. We can use our shortcut. So what's going to go in the parentheses here? Awesome. X plus 6 squared. So when we have a perfect square trinomial, your answer is going to be squared. But for number 6, I'm going to rewrite it here on the side. Let's say we had x squared plus 12x plus 36. What are 2 factors of 36 that add to 12? That add to 12. 6 and 6. So we'd write our answer as x plus 6 times x plus 6, which is the same exact thing. Kind of. This is kind of a shortcut. It helps when you have like a perfect square out front, because then you can't just find your factors of the last one like we did there. But if you don't have a number out front, if it's just x squared, then you can factor it normally. All right, another 5 and 6 on the last page. What's special about x squared and 49? Yeah. X squared and 49, what's special about those two? They're perfect squares. So let's take the square root of x squared and the square root of 49. What's the square root of x squared? X. And the square root of 49? 7. So in the middle, do we have 2 times x times 7? Is that 14x? Yep. So we can use our shortcut. So what's going to go into the parentheses squared? Awesome. X minus 7. Minus because we have a minus in the middle. Perfect. And then for number 6, what's special about x squared and 100? Perfect squares. So what's the square root of x squared? X. And what's the square root of 100? 10. In the middle, do we have 2 times x times 10? Yep, that's 20x. So we can do our shortcut. So what's going to go into my parentheses squared? X minus 10.